Hello. Today we are covering converting circles into descriptive form. So just a little quick warm-up, kind of review from 7.1. Identify the center and radius of the circle. So remember, our general form, our descriptive form is x minus h, that quantity squared, plus y minus k, that quantity squared equals r squared. Remember, that's the descriptive form. That's the form that we went over in 7.1. So our warm-up is in that form. So the center, remember, is going to be opposite of the plus 3. Because remember, the center is hk. And your radius is going to be r. So this would be negative 3, comma, opposite of minus 2 would be positive 2. And then your radius would be the square root of 100, which is 10. Okay, so what happens when the equation is not set up in, it's set up in standard form, and we can't identify everything? So the one we just did was in descriptive form. So if it's in standard form, which is example 1, that's standard form, and example 2, those are standard form. We're going to complete the square. So remember, we started working on this at the end of 7.1. So as I look at example 1, right, I can tell it's a circle because it's x squared and y squared, and it's plus. So I know it's not a quadratic because x and y are both squared. So we want example 1 to look like the descriptive form up here in orange, which I'm underlining in red. We want to take example 1 and make it look like that orange equation. So notice that has two perfect squares. So we are going to make perfect squares by completing this square. We're going to make perfect square binomials. So we might have to do it twice. So your first couple steps are to group your x's and y's together on one side and put your constant on the other side. So I have x squared and 8x. So I'm going to group those together. And I'm going to complete the square, so I'm going to leave space for that new number I have to add to both sides. Then I'm going to group my y's together. So plus y squared minus 18y plus my new number. And then I'm going to subtract 93 over. And notice I'm adding two numbers to the left, so I have to add two numbers to the right. So this is how you set it up. Group your x's together, leave space for the new number. Group your y's, leave space for the new number, move your constants over to the other side, and if you're adding two numbers to the left, you have to add two numbers to the right. So now, all we're going to do is we're going to complete the square. So we're going to take our b term, which would be 8x, divide that by 2, so 4, square it, so 16. And we added 16 to the left, so we're going to add 16 to the right. So remember, right, we're turning this trinomial here into a perfect square binomial. So it factors into x plus 4 squared. How did I know it's plus 4? Because this is a positive 4. And that is always going to end up being the binomial that's squared. Now I'm going to repeat the same process, but now for the y. So I'm going to divide negative 18 by 2, which is negative 9. Square it. So it's 81. If I added 81 to the left, I'm going to add it to the right. Because again, we're just changing the way the equation looks, not its value. So whatever I do to the left, which I added two numbers to the left of the equation, I have to add two numbers to the right of the equation. So now what does this trinomial in green, which I'm underlining in orange right now, what does that factor to? Well, you don't even have to think about it. The answer is right here. So this would be y minus 9 squared equals. So again, when you take that b term and you divide it by 2, whatever that expression is, that's what your trinomial is going to factor to. There's no guesswork. So now on the right side, right, I'm going to add those three numbers up. Right, so these three numbers I'm underlining in bright green. I'm going to add those up. And when you do that, you get 4. So now, if you look, my equation is now in what we call descriptive form, and it looks just like the orange one up there in the top right corner. So now I can find my center. Right? So my center would be opposite of plus 4, so minus 4. Opposite of minus 9, so positive 9. And your radius would be the square root of 4, which is 2. Okay, so let's try it again. So example 2. So again, I see x squared, y squared. It's a plus, so I know it's a circle. It's not a quadratic because x and y are both squared. So I'm going to group my x's together. So I have x squared and minus 6x. So leave space for the new number. Then I'm going to group my y's. Oh, there's only a y squared. There's no other y's, so there's nothing to group, so it's just y squared. So that's already a perfect square. I don't have to complete the square. So that means it hasn't been shifted up and down. It's just going to be shifted left and right because we're completing the square in the x. And then I'm going to add 40 over. So now I'm only adding one number to the left, so I'm only going to add one number to the right. So if you don't have x's or y's, you only have a y squared or an x squared, that means it hasn't been shifted. So you just have the y squared. So in this case, I only have to complete the square once. So the b term's negative 6, divide by 2, negative 3, square it. So I add 9 to the left. To preserve equality, I have to add 9 to the right. And again, now I've created a trinomial in the x squared minus 6x plus 9 that will factor into a perfect square binomial. And you don't have to guess what it is. It's x minus 3 squared. That quantity squared. Plus y squared equals, add 40 and 9 to get 49. So now I have my equation. It's in descriptive form. So my center, right, the minus 3, so this would be positive 3. Okay, y squared, there's no number added or subtracted, so it's 0. So it hasn't been shifted from the origin up or down. It's just been shifted right 3. And then your radius would be the square root of 49, which is 7. Okay, number 3. So same idea. I see x squared, I see y squared. So I know it's a circle. It's not a parabola. So I'm going to group my x's together and group my y's. So I have x squared and minus 5x. So leave space for the new number. And then I have y squared plus 4y. So plus 4y, leave space for the new number. Move the 23 over 4 over. And I'm adding 2 numbers to the left. So I'm going to add 2 numbers to the right. So some of you might be wondering, well, how do you know when to complete the square, like on the x's or the y's? Well, in order to complete the square, you have to have a squared term and an x to the first power, or y. So I have x squared and 5x, so I can complete the square. I'm missing that constant term. Same thing with the y. I'm missing the constant term. So in order to complete the square, you have to have the a, which is the squared term, and the b term, which is the term with a variable to the first power. So you have to have an x squared and an x, or a y squared and a y. Otherwise, you can't complete the square. You got to have 2 of the 3. And we're trying to make a trinomial, so 3 terms, that factors into a perfect square. So if you don't have 2 of the 3 terms, you can't complete the square. That's what happened on the example above. All we had was the y squared. It's already a perfect square, right? It's the same thing as writing y minus 0 squared. That's a perfect square. We just don't write the 0. So we're going to complete the square. So the b term, we divide by 2, so negative 5 halves. Square it. So that'd be 25 over 4. So I'm going to add 25 over 4. Now, I'm not converting it to a decimal because I have 23 over 4 over there. So I'm going to end up having to add fourths together, so I'm just going to keep it as a fraction. So this factors, right? Oh, this looks really confusing. No, it's just x minus 5 over 2. And then repeat. Take the b term, which is 4, divide by 2. So 2 squared. So I'm going to add 4 to both sides. So this becomes y plus 2. Now on the left side, we're good. Right side, we have to combine those. Now we have 23 over 4, 25 over 4, right, and 4. So if we're going to combine those, we need to make 4 into fourth. So 4 over 1, right, we're going to multiply by 4 over 4 to get 16 over 4. So now I can add all those together. Right, 23 and 25 is 48 divided by 4 plus 4 or plus 16. All that eventually will reduce to just 16 if you add up all three of those. So now I can find my center. All right. So opposite of this, so this would be 5 halves. Opposite, minus 2. And your radius would be the square root of 16, which is 4. Again, why is it the square root of 16? Because the equation is r squared, and I want r. So I square root whatever the number is in the equation. Okay, so example 4. Show that the circle with this equation is congruent to the circle with a center of 0 and radius of 3. And then indicate the translation needed to map the first circle to the second. So just a reminder, the first circle has a center of 0, 0, a radius of 3. So here's the equation. So we're going to take this equation here, we're going to convert it into descriptive form, and we're going to find out if it has the same radius, then it's a congruent circle. Circles are congruent if they have the same radius. It doesn't matter what's their center, it's do they have the same radius. Then they're going to be congruent. So we're going to complete the square. So before we do that, we need to distribute. So x squared plus y squared plus 20 equals 10x minus 4y. So again, just like we did on the previous 3 examples, we're going to put our x's together and our y's, and our constant we're going to move over. So that means I'm going to move the 10x and the 4y over, and I'm going to move the 20 over to the right. So x squared minus 10x plus a new number plus y squared plus 4y plus a new number is going to equal minus 20. And I'm adding 2 numbers to the left, so I'm going to add 2 numbers to the right. So again, I subtracted 10x and added 4y to move them to the left side, and I subtracted 20 to move it to the right side of the equal sign. So now I can complete the square. B term, divide by 2, negative 5 squared. So it's 25 because you're squaring it. So 25. So this is x minus 5 squared. All right, now repeat the same thing for the y. The b term is 4, divide by 2, square that. So I'm adding 4 to both sides. So this is y plus 2 squared. And then on the right, we're going to add these 3 numbers together. So negative 20 plus 25 plus 4. So 5 plus 4 is 9. So the center would be positive 5, negative 2. And the radius would be the square root of 9, which is 3. Again, how do I find the center? I have it in descriptive form. Remember, it's the opposite value of the equation is what the point is for the center. So minus 5, the point will be positive 5. Plus 2, the point will be minus 2. It's opposite. The radius is just the square root of the number in the equation, the constant. That's your radius. So it has a radius of 3. Our original equation has a radius of 3. So yes, they are congruent. So now, how do we go from our first circle, which is at 0, 0, to 5, 2? Well, we would go right 5 and down 2. And again, they are congruent because they both have the same radius. They're both a radius of 3. It doesn't matter they have different centers. Circles are congruent if they have the same radius. Wait, remember the warm-up problem we did. We identified the center and the radius. So remember, the center was -3, +2, and the radius was the square root of 100. Right? We did that at the beginning of the notes. So we want to make the circle twice as big. So what would we do to make that happen? What part of the equation? Do we affect the center or the radius to make the circle twice as big? So think about that. What actually determines the size of a circle? So hopefully you were just thinking the radius, because that would be correct. So if I want to make a circle twice as big, I need to make the radius bigger. So how do we dilate a circle that has a scale factor of 2? How do we make it twice as large? So our radius is 10, twice as large, we're just going to double it. So the radius would be 20. So what would be our new equation? Well, the center hasn't changed. So it's x plus 3 squared plus y minus 2 squared equals 20 squared, right? Because it's r squared. 20 squared would be 400. So that would be the equation of your circle. So example 5. Show that the circle with that equation is a dilation of the circle with a center of -3, 1 and a radius of 8. What's the ratio of the dilation? So if it's going to be a dilation, it's just the same circle enlarged. Okay, so we need to first figure out the center and the radius of that equation. So we need to get this into descriptive form. We need to make it look like the blue equation right above it that I just underlined. We want our black, the equation there, to look like the blue one. So we're going to distribute. So we have x squared plus 6x. We're going to complete the square, so we're going to leave space for a new number. And then the same idea with the y. Plus y squared minus 2y plus room for a new number. And then we're just going to leave the 134 over there. And again, I'm adding 2 numbers to the left, so I'm going to add 2 numbers to the right. And again, I encourage you to put these placeholders in, so you know you need to put a number at all 4 of those placeholders. So we have 1x squared and 1y squared. So we're going to complete the square, divide the b term by 2, so 3, square it. So you add 9 here and 9 to the right. So this trinomial factors to x plus 3 squared. Again, whatever this expression is, when you divide by 2, that's what it's going to factor to. You don't have to figure out what it factors to. It gives you the answer. B term is -2 divided by 2, -1 squared. You're squaring -1, so +1, +1. So this becomes y minus 1 squared. Again, B term, divide by 2, whatever that equals. That is what it factors to. Okay, and then we add up everything on the right side here. These 3 constants. It's going to give me 144. So your center, again, opposite, -3, opposite, +1. Radius, square root of 144, which is 12. So notice has the same center as our circle, -3, 1. And the radius is 8, and now it's 12. So that is a dilation. You took this circle at the exact same location, and you just made it bigger. So that's a dilation. Or if you would have shrunk it, it would be a dilation. So the ratio, however you want to look at this, it doesn't say which circle to start with. So the dilation ratio, again, it doesn't say which circle to start with. I guess we'll start with a smaller one. So 8 to 12. So that would become 2/3. I mean, it is dilation, so if you went 12 over 8, either one of those would be fine. It doesn't really state which circle to start with, so whatever one you started with would be fine. But again, it's a dilation because it's the same circle, because it started at the same center, and the radiuses are different, so it just was enlarged. So again, remember, as you complete the square, couple things. Your squared term has to have a 1 in front of it. If it's not a 1, you got to make it a 1 by division or multiplication. Your x's are grouped together, y's are grouped together, constants are on the other side. If you add 2 numbers to the left, you got to add 2 numbers to the right. Take the b term, divide it by 2. Whatever you do when you divide by 2, whatever answer you get, that's what it factors to. Once you divide by 2, square that number, add it to both sides. You complete the square on the left or right, whatever side you're doing it, and then you add your constants on the other side, and now we're in descriptive form, so we can easily find the center and the radius. So make sure you answer the essential question at the top of the notes with a 3 to 5 sentence summary, and you'll be done with your notes. Have a great day.